You look at the transformations of a log function, it's just like every other transformation we've done. If you have h, you're going to move your graph h units left and right, k units up and down, and then you have a vertical translation or reflection over the x-axis if it's negative. So let's take a look at example 7. So what happens is, I notice I'm going to have a vertical translation of 1. You're going to move your graph up 1. And you're going to have a dilation by a factor of 3. So we're going to multiply by 3. It's just going to go up 3 times as fast. So normally, what I'd be at 0 and 1. Well, I'm going to be at 1 and 1 because I'm up 1. And then we're just going to raise a little bit higher than you normally would. We can look at this with technology. And there's our graph. And that's what it kind of looks like. Not kind of looks like. That's what exactly it looks like. If I take a look at my second example here, I notice I'm going to have a shift of 3 to the right. And then have a dilation by a factor of 1/2. So normally I would be at 0 and 1. So I want to move it 3 to the right, so I want to be over 4. And then it'll be a little bit, it'll go down a little bit slower. Let's take a look at that one with technology. So if I have 1/2, I'm going to do log to the base of 0.25. Of x minus 3. Notice it gets moved over 3 to the right. And it goes a little bit, every point is multiplied by 1/2. So it falls a little bit slower. And that's what all you would do on that. Let's take a look at example 9. It says at the surface, the air pressure is defined as 1 atmosphere, decreases by about 20% for each mile of altitude. Altitude pressure can be modeled by P equals 0.8 to the x power, where x is measured in miles. Find the atmospheric pressure and atmosphere at an altitude of 8 miles. So in other words, we're going to just replace x with 8. So the pressure equals 0.08 to the x power, which is 0.08 raised to the 8th power. I think we'll use a calculator for that. So we'll just take 0.8, we'll raise that to the 8th power. And we get about 0.168. That we atmospheres. That's how we measure pressure.